replacement reactions are our next type of reaction, and this is where a single element in a compound are going to react, and one of the elements in the compound might get replaced. So looking at these two sample reactions at the bottom here, A plus BC, what is it going to yield? So A is positive in this example. A is going to replace the thing that is just like it, the other positive thing. So A and B might switch places. So B will get kicked out and A will bond with C. Remember, A has to be first because it is positive. Cations always go first. Now, in the second one, D is negative and it's all by itself. So D is going to replace the thing that's just like it, which is going to be C, because C is that anion in that compound. So C is going to get booted out, and it's going to be BD as your product for if we're replacing a negative ion in that case. The reaction doesn't always have to take place. We've got a tool that we can use on page 7 of your reference table, and it's called the activity series. Now, this is what it's going to look like if you switch to that page on your reference table. This is the activity series. There's 2 different ones. Anything in the top activity series cannot replace anything in the bottom one. Anything in the bottom cannot replace anything in the top. So it's only in its own activity series that it will react. If it's higher up, it's stronger, which means fluorine is the strongest. It can replace whatever it wants, and lithium is the strongest. It can replace anything it wants. Fluorine can replace chlorine, bromine, and iodine. Chlorine can only replace bromine and iodine. Bromine can only replace iodine. Iodine can't do anything. And same thing for the metals. So lithium will replace whatever it wants. Rubidium can replace most everything except lithium. So if it's the highest up, it's the strongest. So let's do some examples just to show how this works. Lithium plus NaCl. So I'm going to look if lithium is strong enough to replace sodium. Lithium is a metal, so it's going to replace the metal. So is lithium stronger than sodium? Yes. Lithium is all the way up here and sodium is right down there. So lithium is definitely going to replace it. So sodium's going to get booted out and we're going to be left with LiCl. Now, just a forewarning, anytime we make a new compound, we have to crisscross those charges. Lithium has a +1 because it's in group 1. Chlorine has a -1 because it's in group 17. We get LiCl because they're just ones. So make sure you do those crisscrosses every time you make a new compound. For this next example, fluorine is going to be replacing something. Fluorine is in the top list, so it can only replace anything in this list. So it looks like it's going to try and replace iodine, which is right here. Can fluorine replace iodine? Absolutely, because fluorine is that top number. So iodine is going to get kicked out. And you're going to be left with Mg forming with F. Well, magnesium is in group 2, so it has a +2 charge. Fluorine is in group 17, it has a -1 charge. When we crisscross those, we're going to be left with MgF2. So I'm going to add that to my product for that example. The third example, Pb plus CaO. So lead here is going to try and replace the calcium. So is lead higher than calcium? Well, let's see here. I see calcium right here and lead is all the way down here. Lead is not stronger than calcium, which means no reaction will happen. And that's all you have to do. And then lastly, iodine here is going to try and replace the chlorine. How do I know that? Because iodine and chlorine are in the same list right here. Iodine, however, is all the way at the bottom. It can't replace anything. So again, no reaction will form.